Alright guys, so for today, we're going to start looking at some triangles and we're going to use what we call trigonometry. Trig is a little section of geometry. You guys expand it a little more in Algebra 2, and you guys expand it a little more in Math Analysis, and on and on. And there's even a whole, in college, there's a class, a whole semester, only about trig. So trigonometry. There's three, let me minimize this first. There's six names we're going to be looking at. The names we're going to be looking at are sine, cosine, and tangent. You guys don't have to write this thing down. I'm just going to talk about this real quick. Sine, cosine, tangent. And then we have cosecant, secant, and cotangent. For today, I'm only going to focus on sine and cosecant. So, matter of fact, they abbreviate this, the first three letters on your calculators. Some of you guys have seen sin in the calculator, they represent sine. Cosecant, they're not going to abbreviate it with COS because cosine starts the same way. So cosecant is going to be abbreviated as CSC for cosecant. And then on a right triangle, starting with the right triangle, we know the biggest side is the hypotenuse. Right? We've been working with that for a good while. We know the biggest side is the hypotenuse. But then depending on the corner where we look at, if I'm looking at this from this corner, I'm going to say the farthest side from here will be called the opposite. Kind of like when you guys are walking on the streets, the opposite side of the street is what's farthest away. So that we're going to call that opposite, farthest away. And then this third side, the one right next to the angle, we're going to call it adjacent. Adjacent is the fancy word of saying next to. So not far, next to. So like I said, depends on where you're looking at it from. If I was looking at it from this other corner, this will be my opposite, and this will be the adjacent. So opposite and adjacent switch depending on where you're looking at it from. Hypotenuse is always the biggest. Like hypotenuse doesn't change. Only opposite and adjacent depends on where you're looking at it from. The way I'm going to indicate the corner that I'm looking at this from, let me close this. The way I'm going to indicate the corner, I'm going to use a little sign, a Greek letter. It looks like an O with a little line in between it. That is theta. That's how it's called. Let me spell it out for you. Theta. I'm going to put a little theta just to indicate which corner we're looking at it from. So the little Greek letter is just to indicate where we're looking at from. Now sine, you guys have seen on my wall, SOHCAHTOA. So sine is going to be opposite over hypotenuse. That's why I call it so. Now cosecant is the reciprocal of it. So it's going to be hypotenuse over opposite. Just to make a little more sense of this, let's take a look at the work. Let me label this the way I know the sides. I know the hypotenuse is the bigger side. From theta, so from this corner, the one that is farthest away, that's the opposite, and this is my adjacent. Now for sine, like I said, we have on the board, so what sine is opposite over hypotenuse. I have a value for opposite, I have a value for hypotenuse, so I'm just going to write 3 over 5. That is it. Right? For sine, we don't use adjacent. We only use opposite over hypotenuse for sine. If I look at question number 2, this is my theta. I know the hypotenuse is 25. From my theta, this is my opposite, and this is the adjacent. I know sine. Once again, it's sine. I have so. Sine is opposite over hypotenuse. So I'm going to go 5 radical 21 over 25. In this case, we can simplify the fraction. 5 over 25, I'm going to simplify that as radical 21 over 5. Right? 5 over 25 can be simplified. So simplify your fractions. And then your radicals, simplify them too if you can. And make sure no radicals at the bottom. And we know if there's a radical at the bottom, remember, rationalize. Multiply top and bottom by the radical. Let's take a look at question number 3. 17 is the hypotenuse. From theta, the one that is farthest away is the opposite. 15 is the adjacent. What fraction do you guys get for sine of theta? 8 over 17. Nice. That's simple. Right? Opposite over hypotenuse. Now let's take a look at a cosecant. Question number 4. So I'm going to label them the same way I was doing for sine. 17 is the hypotenuse. From theta, this is the opposite, this is the adjacent. I know that sine is opposite over hypotenuse. I told you guys that cosecant is the reciprocal. So instead of going opposite over hypotenuse, I'm going to go hypotenuse over opposite. So let me write this as 17 over 4 radical 15. Hypotenuse over opposite. Remember, cosecant is the reciprocal. So if we flip it, I'm going hypotenuse over opposite. I cannot have radicals at the bottom. So let me multiply top and bottom by radical 15. On the top, 17 times radical 15, I cannot combine them. So I'm just going to write them out. 17 radical 15. At the bottom, I know radical 15 times radical 15 is 15. Times the 4 gives me 60. Then I double check my fraction. 17 over 60. If we can simplify, simplify. In this case, we cannot. Like I said, double check your fraction if you can simplify. All right. Any questions? No? Let me take roll really quick.